Hello, this is Erin Griswold, and my research project is about BIM and robotic use on site on construction projects. The outline for this presentation is the introduction, which includes the background and motivation, the keywords, the overview of the literature collection, the detailed analysis of the selected literature results, and the conclusion. Introduction. Architecture, engineering, and construction are innovative fields that are constantly looking for the next advent that will increase productivity in their sector. As a result, researchers have studied various emerging technologies that may have beneficial impact on the construction process. This study aims to investigate the impact of using BIM and robotics on site of construction projects to increase productivity, quality assurance, quality control, and safety. The construction industry is a pivotal sector of many countries' economies. In the United States, the construction industry comprises of 7.6% of the total workforce. Globally, McKinsey Global Institute estimates that $10 trillion is spent on construction-related activities every year. The institute also projects that increasing productivity growth could decrease construction-related spending by as much as $1.6 trillion a year. So with so much money being contributed to this sector, it is imperative to research ways to limit spending as much as possible. In addition, I performed QA/QC and in-wall and above-ceiling inspections for a 41-story high-rise during my internship with a general contractor, which gave me personal experience on how robotics could help facilitate the construction process. QA/QC is mainly done by human personnel currently, and the repetitive nature often leads to frequent human error. The addition of robotics on site would help to reduce these errors. In addition, construction work is one of the most dangerous lines of work globally. Each year, it is estimated that 1/6 of all fatal occupational accidents occur on construction sites. The addition of robotics on job sites will limit the need for human personnel involved in dangerous construction activities. While research on robots is vast, research regarding the utilization of robotics on site of construction projects is limited. Yet this is an important area to be knowledgeable of due to its impact on economy and safety. The key words of my literature review are robotics, building information modeling, or BIM, on-site, quality assurance and quality control, or QA/QC, and productivity. Collection of literature. Peer-reviewed papers relevant to the use of BIM and robotics in construction projects were retrieved through two database websites, Semantic Scholar and Google Scholar. Focusing on the keywords presented in the abstract of this paper, information was collected regarding BIM and robotics impacts on construction productivity and safety, as well as reasoning of slow adoption of these technologies. The literature review contained 13 scholarly articles, focusing on articles written in the past 15 years. As technology has advanced, there has been an increase of research papers studying these tools. Few articles were published before 2010. However, there has been a dramatic increase of papers published about this topic since 2015, with most papers extracted from 2023, as seen in Figure 1. As BIM and robotics can be utilized globally, the research was not confined within the United States and includes case studies from areas such as Canada, Italy, Japan, and Malaysia. In addition, in order to ensure the selected papers were relevant to the chosen topic, a word cloud was generated out of the abstracts of the paper. The largest words in Figure 2 indicate the most frequently used words in the abstracts. The most frequent words in the abstract are BIM, robot, building, information, and safety, which correlates with the chosen research subject regarding BIM and robotic use on construction projects to increase productivity and safety. Other frequent words include inspection, object, information, system, and navigation, which indicates terms related to specific implementation strategies of these technologies. After analyzing the word cloud, it is evident that selected articles align with BIM and robotic applications in construction sites. The following figures provide insight into findings from the selected literature. Building information modeling's ability to hold a vast amount of information paired with its easy program navigation, can have many benefits for construction managers. Figure 3 highlights 6 of the advantages that come from using BIM on construction projects. These include fast learning curve, flexibility of generative tools, interoperability of 3D laser scanning data, high detail and accuracy, interoperable formats and schemas, reduced production cost and labor time. The importance of this study is indicated by Figure 4. Implementing construction management technologies not only benefits the productivity and safety of construction managers and workers, but also benefits other stakeholders in the industry, such as the building owners and architecture firms. This is due to the increased communication in regard to updated plans and schedules, and minimizing errors before and during construction. Figure 5 outlines the process of integrating BIM with robotics in order to perform tasks on site. BIM first creates an interoperable 3D model that communicates perimeters to the robotics. Then the robot is able to use IFC object detection to navigate the site and perform tasks. Safety is a major priority of the construction industry. Innovative technologies such as BIM and robotics can help to decrease construction-related injuries. As seen in Figure 6, falling from high heights was the #1 cause of fatal and non-fatal accidents in Japan between 1999 and 2021. Robotics such as drones can minimize work in dangerous areas such as building exteriors. Although the robotic technologies have become increasingly beneficial in the last decade, there has been a slow adoption of these products in construction sites. Figure 7 highlights some of the disadvantages of implementing BIM in the construction projects. The main reason found from multiple scholarly articles was the high cost of these technologies, followed by the interoperability issues and required training. Figure 8 details ways that the application of BIM and robotics can be increased in the industry. These methods include increasing the research and development programs and providing incentives that encourage companies to invest in these products. Detailed analysis of selected literature. Due to the knowledge of Google Scholar being more lenient on publications, the study extracted articles primarily from Semantic Scholar. In addition, the literature review was primarily focused on articles written after 2015 in order to ensure the most up-to-date information was researched. The global analysis may lead to discrepancies in regard to applications of this research in the United States. One of the sources describes safety in Japan as indicated by Figure 6. Japan's safety standards are different than the United States standards set by OSHA. Therefore, their vitality and injury rates may be higher than in the States. The 4 research questions of this paper were: #1, what are the parametric modeling and project life cycle abilities of BIM? 2, what are the benefits of using BIM and robots on site construction projects? 3, how can robotics be used to update project systems such as BIM? 4, what are the challenges facing the implementation of new technologies in the construction industry? And in conclusion, this study has conducted a systematic review of the literature regarding BIM and robotic applications on site of construction projects. The study findings recommend the implementation of these technologies to increase productivity of construction projects. This in turn leads to shorter project timelines and a decrease in construction-related injuries. Although there are limitations to utilizing these tools, such as cost, training, and project complexities, BIM and robotics can be very beneficial for a variety of stakeholders and minimize human-related errors that may occur during the construction phase of a project. And here's my list of references. Thank you.